Lesson 32, second lesson of the week, so make sure you have that out in front of you. We're going to use trigonometry to find side lengths of an acute triangle. Alright, so let's go ahead and look at this. The objective for today is to find missing side lengths of an acute triangle, given one side length and the measure of two angles, and to find the missing side lengths of an acute triangle given two side lengths and the measure of the included angle. Alright, so let's just go ahead and look at A and B. Find the length of D and E. Alright, so we're looking for the length of D and E. Well, I can't use Pythagorean theorem because I do not have the measure of two sides. So let's go ahead and use what we know. Let's just go ahead and look at the sine or the angle of 60. Alright, and let's think about what I can do with that. Well, sine is opposite over hypotenuse. I have my opposite. I can use this to find my hypotenuse. Alright, so the sine of 60 is equal to opposite, which is 5, over hypotenuse is E. Alright, so if I multiply everything by E, I end up with E sine of 60 is equal to 5. Divide by the sine of 60. Alright, so I would find E is approximately, alright, so we're going to get our calculator. Once again, remember, I can use, if you have a scientific calculator, if not, your cell phone, turn it sideways and it should give you a calculator. Alright, so I have 5 divided by, I got to move my calculator, guys, there's a glare. Alright, sine of 60, which gives me approximately 5.7735. Alright, now you can leave it that way. Does not matter, that's fine. Or you could try to solve it using radicals, but we're going to do 5.78. Alright? Alright, so 5.78. Then I can, looking at this, the 30, this is adjacent over hypotenuse, but that's not going to help me. So how might I be able to do this? Well, I can do Pythagorean theorem, whatever your choice is. 5 squared plus d squared is equal to 5.78 squared. Now remember, this is going to be an estimate because I did round, so I get 33.41. Subtract 25, and I get 8.41. Take the square root of 8.41, and that gives me D is approximately 2.9. Okay? Alright. Find the lengths of X and Y. How is this different from part A? Well, let's look at X and Y. How is this different? Well, here's what you need to recognize first. This is not a right triangle. Alright? This this is not a right triangle because I do not have a right angle marked. It may look to be a right triangle, but guys, in geometry, you cannot assume. You have to know for sure. So nothing is marked as to being a right triangle. So let me ask this question. Can I use sine, cosine, tangent? I cannot. Trigonometric ratios are not applicable here. They are not, we cannot use them. So we cannot use trig ratios because this is not a right triangle. All right? So, let's talk about the laws of sine for acute triangles. Today we will show how two facts in trigonometry aid us to find unknown measurements in triangles that are not right triangles. We can use these facts for acute and obtuse triangles, but today we will specifically study acute triangles. The facts are called the laws of sine and the laws of cosines. We begin with the laws of sines. All right. So, the law of sines. I want to make sure it wasn't already written out for me. All right, so the laws of sines says for an acute triangle ABC with angles A, angle B, and angle C, and the sides opposite them as small a, small b, small c, the law of sine states that the sine of angle A divided by A is equal to the sine of angle B divided by B is equal to the sine of angle C divided by little c. Okay, so this is an acute triangle labeled A, B, C, and the sides opposite being A, B, C. So it's telling me the side of angle A divided by the side opposite it is equal to the sine of angle B, which is divided by the side opposite. And angle C, the sine of angle C would be divided by the side C. All right? Now, this may be difficult for you to understand, to get, okay? The ratio of the sine of an angle, of a triangle, to the side opposite the angle is the same for each angle in the triangle. Okay, so let me repeat that again. The ratio of the sine of an angle in a triangle to the side opposite the angle is the same for each angle in the triangle. All right, so let's just kind of consider a triangle here. So let's consider triangle ABC. All right, I'm going to label the sides opposite it with the lowercase letters. All right, and this triangle is going to have an altitude from angle B to AC. All right, now, since we know we have an altitude, then we know that we form right angles at the bottom. All right? So now, look what we have. Okay. We're going to label this H. So now, what is the sine of C? All right, so let's say the sine of C. and I am looking at the sine of angle C. So sine is opposite over hypotenuse, which would be h over a. So now, if I were to solve for h, I would multiply everything by a, and I would get a times the sine of angle C is equal to h. Alright? What is the sine of A? Let's look at the sine of A. I'm going to mark this over here so we can kind of compare them. The sine of angle A is opposite over hypotenuse, which is C. Alright? So once again, if I solve for h, I get C times the sine of angle A is equal to h. So what can we conclude so far? Well, since h is equal to a sine of angle C, and h is equal to C sine of angle A, then here's what we can say. We can say that the A sine of angle C is equal to C sine of angle A, because they both equal h. Okay? Now with a little algebraic manipulation, we can rewrite A sine of angle C is equal to the C sine of angle A as something else. Well, if I divide both sides by A and divide both sides by C, look what happens. I get the sine of angle C divided by C is equal to the sine of angle A divided by A. So we have partially shown why the law of sines is true. What do we need to show in order to complete the proof, and how can we go about determining this? Well, the next thing that we need to do is we need to show that all of this is equal to the sine of angle B over B. Alright? So let's say that we draw a different altitude. Alright? So if I do a different altitude, alright, let's see A, C, B. Let's say I draw an altitude from A to BC, or yeah, BC. Alright, we'll label that H. Then let's talk about this. An altitude from A gives us the sine of B. So let's look at the sine of B, opposite, which is H, over hypotenuse, which is C. Alright? Or if I rewrite that, I get C times the sine of angle B is equal to H. Alright? So, if you remember, sine of A was H over C. And since we know that sine of A and sine of C are equal, well, they're all equal. So now I can go back to my law of sine and say that the sine of angle A divided by A is equal to the sine of angle B divided by B is equal to the sine of angle C divided by C. Alright? So we have proven the law of sine. Alright, so let's go ahead and look at example number 1. A surveyor needs to determine the distance between 2 points A and B that lie on opposite banks of a river. A point C is chosen 160 meters from point A on the same side of the river as A. The measure of angles BAC and angle ACB are 41 and 55 respectively. Approximate the distance from A to B to the nearest meter. Alright, so let's think about this for just a second. They have drawn us a diagram. So we've got, they need to determine the distance between point A and point B. Alright. C is chosen 160 meters from point A on the same side of the river as A. The measures of angle BAC is 41 and ACB is 55. Approximate the distance from A to B. Okay, so what measures can we add to the diagram based on the provided information? Well, can I figure out this angle here? I can, because I can say 55 plus 41 is equal to 96, and then I can subtract that from 180, so I get, what, 84? So I know that this is 84 degrees. Alright, what else can I add? Well, I know that this is side A, and that this is side C. Alright? So I can use the law of sines to set up all possible ratios applicable to the diagram. Okay? So let's look at this. The law of sine was the sine of angle A. Alright, so the sine of 41 divided by A, which I don't know, is equal to the sine of angle B, which is the sine of 84, divided by, well, I know that, that's 160, is equal to the sine of angle C, which is 55, divided by C. Alright? So all I'm doing is using the law of sine here. Which ratios will be relevant to determining the distance from A to B? Alright? I want to know the distance from A to B. Well, that is the letter C, so it would make sense. I don't really need to know A, so it would make sense to use these two ratios. So I would use the sine of 84 over 160 is equal to the sine of 55 over C. Alright, so I'm going to solve. Alright, so I'm solving for C. So I would cross multiply since it's a ratio. Alright, so I have 160 sine of 55 is equal to C sine of 84. How do I solve for C? Because that's what I'm trying to find. I'm going to divide by the sine of 84. Alright, so then I get C. Am I going to have an exact answer? I don't know. We'll have to see. Alright, so getting my calculator. We're going to enter this in. So I have, I guess I need to finish this. Sorry. I have C is equal to 160 sine of 55 over the sine of 84. Alright, so now I've got to enter that into the calculator. So I'm going to use parentheses. So 160 times the sine of 55 divided by, parentheses, the sine of 84, and I hope with the glare that I entered that correctly, and I would get this, 131.786, so we're going to say C is equal to, and round to the nearest meter it says, 132 meters. Okay? These require just a little bit more work, but I don't think they're extremely difficult. Alright, let's look at exercise 1-2. In triangle ABC, the measure of angle A is 30, the lowercase a is 12, lowercase b is 10. Find the sine of angle B. Include a diagram in your answer. Alright, well, we have a diagram. Let's go ahead and think about what's going to be important. If I set up all of my ratios, alright, so I know the sine of A, sine of 30, is equal to 12, or divided by 12 is equal to the sine of angle B, which we don't know, over B is 10, is equal to the sine of C. I don't know what angle C is either, over, I don't know what little c is. So which of these are going to be beneficial if I'm trying to find angle B? Well, I don't know anything about C, so my ratio is going to be set up as the sine of 30 over 12 is equal to the sine of B over 10. Alright? Cross multiply. I get 12 sine of B is equal to 10 sine of 30. I am trying to find the sine of B, so I'm going to divide by 12. So I get the sine of B is equal to 10 sine of 30 over 12. Alright, so we enter this into our calculator. And I get 10, I'm going to once again use parentheses, 10 sine of 30 divided by 12 gives me approximately 0.416667. Let's see what we did wrong. Well, let's see what I did wrong. I don't even have to do all of this. I actually went way more than I needed to do. If I look at this, the sine of angle B would actually just be this, 10 over 12, which is, let's do 10 sine of 30. Sorry, guys. If I multiply 10 sine of 30, which I do need to keep this, I get 5 over 12. So I'm not going to put, I don't know what I did in the calculator. So I must have hit something wrong because I should get 5 over 12. Alright? So don't put it all in the calculator at once. Figure out the top and then you have the bottom. So the sine of B is 5 over 12. A car is moving towards a tunnel carved out at the base of a hill. As the accompanying diagram shows, the top of the hill H is sighted from two locations, A and B. The distance between A and B is 250 feet. What is the height H of the hill to the nearest foot? Okay, so let's look at this one. Let's go ahead and label everything that we know. All right, so it tells me that the distance between A and B is 250 feet. I want to know what is the height. Okay, so we're going to use the lesson that we talked about, angle of depression, angle of elevation. Since I am looking down, then I know it is an angle of depression. All right? The angle of depression from H to A is 60 degrees. All right? Now, they don't tell us this. So I'm giving you information that's going to help you. All right? So the angle of depression from H to A is 60 degrees. That means this whole entire angle right here. All right? So that's 60 degrees. And the angle of depression from H to B is 45. All right? So that means that this angle right here is 45 degrees, which means that this angle right here is 15 degrees. All right? So we're going to let X represent BH. All right? X represent BH in feet. So let's apply the law of sines. All right? So I can do the sine of 15. So the sine of 15, we're looking at this angle right here, divided by the side opposite, which is 250, is equal to the sine of 30 divided by X, all right? Because this angle here is 30. All right? So this is, and guys, this is a 90-degree triangle, so I know it's a 30, 60, 90 triangle. All right? You can't really see it, but there is a right angle box right there. All right? So it's a 30, 60, 90 triangle. All right. So let's go ahead and solve this. Multiply. I get X times the sine of 15 is equal to the sine of 30 times 250, which I wrote that backwards, but my brain was not thinking as fast as my hand. I want to solve for X. All right. So let's go ahead and look at this. So the sine of 30 times 250 gives me I hit that in wrong. 250 times the sine of 30 is 125. So I get 125 over the sine of 15. All right. So 125 divided by the sine of 15 is approximately 482.963. So we'll round that to 482.96. All right, so X, HB, is 482 and 96 hundredths. All right, now, BH is the hypotenuse of this triangle. All right, now if this is 45, that means this must be 45 because this is a 45, 45, 90 triangle. All right, now if you remember, a 45, 45, 90 triangle has side lengths of 1, 1, and the square root of 2. All right, so I can set up a ratio here. Remember, our whole goal is to find little h, which is this right here. All right, that is our whole goal. All right, so here is my side lengths for a 45, 45, 90 triangle, which is H, H, and H times the square root of 2. Okay? Side, side, and square root of 2. Alright. So I'm going to set it up as H square root of 2 is equal to X. Alright? So I have the H square root of 2 is equal to, now if you remember, X was 125 over the sine of 15. Alright? So multiply everything by the square root of 2. Alright? And I get 125 over sine of 15 times the square root of 2. Alright? So let's figure that out. Sine of 15 times the square root of 2. Alright, so 125 divided by, that answer would be approximately 342 feet. Okay? Alright, guys, I realize that this one was a little bit more difficult. But just bear with me, I promise it's not extremely bad. Alright, so now we're going to get into the law of cosines. Alright? So the law of cosines say this. For an acute triangle, triangle ABC, with angles angle A, angle B, and angle C, and the sides opposite them is little a, little b, and little c, the law of cosine states this, that c squared is equal to a squared plus b squared minus 2ab cosine of angle C. Alright, little bit more difficult to remember, but hopefully by the time you are done using it, you will understand. So the square of one side of the triangle is equal to the sum of the squares of the other two sides minus twice the product of the other two sides and the cosine of the angle between them. Alright, so let's think about what this means. Alright, so let's look at a triangle. Alright. The law of cosine is a generalization of the Pythagorean theorem, which can only be used with right triangles. Alright, so we're going to substitute 90 degrees for angle C. Alright, into the law of cosines formula, and let's look at the results. So C squared is equal to A squared plus B squared minus 2AB cosine 90. Alright? What is the value of the cosine of 90? Well, if you remember the chart that we did, we figured out the cosine of 90 was 0. Alright? So, 0 times anything gives me 0. So look what I'm left with. C squared is equal to A squared plus B squared. This explains why the law of cosine is a generalization of the Pythagorean theorem. We will use the law of cosines for acute triangles in order to determine the side length of the third side of the triangle, provided two side lengths and the included angle measures. Alright, so let's go back to the triangle from example number 1. Alright, so we had triangle ABC, and it was an acute triangle. Alright, so I've got C, A, I'm going to mark all of this as B. Alright, and remember we dropped an altitude, and we labeled that H. Alright, and we'll give this a little d. And E, because we've divided this into 2 parts. Okay, so we're going back to this triangle from example 1. Alright, but this time, the point where the altitude meets AC, we're going to divide it into D and E, because we have now split our B. Alright, so let's express E and H using trigonometry with respects to angle C. So in respects to angle C, let's talk about H. Well, H would be A times the sine of angle C. Alright? E would be A times the cosine of angle C. Now we turn to the right triangle, triangle ABD. What length relationship can be concluded between the sides of the triangle? Well, by the Pythagorean theorem, the length relationship in triangle ABD is C squared is equal to D squared plus H squared. So we're going to substitute the trigonometric expressions for D and H into this statement. Alright? So we have C squared is equal to D squared plus H squared. Let's plug in what we have. Alright? So C squared is equal to D would be B minus E, because B is the whole entire thing, minus E, which was A cosine of angle C, plus H is A sine of angle C. Alright? So we're going to simplify this statement as much as possible. Alright? So let's look at this. I get, oh, I'm sorry. I forgot to square. Alright? So this is what I end up with. C squared is equal to, when I multiply these out, I get B squared minus 2AB cosine of angle C plus A squared cosine squared of angle C plus A sine of angle C squared. Alright? So then I get C squared is equal to B squared minus 2AB cosine of angle C plus A squared cosine squared of angle C plus, let's go ahead and distribute our square here, A squared sine squared of angle C. Alright, so then let's go ahead and combine anything that we can. So I've got C squared is equal to B squared. Alright, minus 2AB cosine of C plus, let's look at this, I can pull an A squared out, and I'm left with the cosine squared of angle C plus the sine squared of angle C. Alright? Now, when I figure this out, the cosine squared of angle C and the sine squared of angle C equals 1. Alright? So I get this. C squared is equal to A squared plus B squared minus 2AB cosine of angle C. Notice that the right-hand side is composed of two side lengths and the cosine of the included angle. This will remain true if the labeling of the triangle is rearranged. Alright? So let's look at example number 2. Our friend the surveyor from example 1 is doing some further work. He has already found the distance between points A and B from example 1. Now he wants to locate a point D that is equidistant from point A and B on the same side of the river as A. He has his assistant mark the point D so that the angle ABD and angle BAD both measure 75, which they've already marked. What is the distance between D and A to the nearest meter? Okay, so let's mark what we know. So this is A, this is B, and this is D. Alright, so it tells us we are trying to find the distance between D and A. I want to know this part right here. Alright? So what do you notice about triangle ABD right away? Well, it must be an isosceles triangle because my base angles are equal. Alright? So we must keep this in mind going forward. Add all relevant labels to the diagram. So we have we labeled everything? Okay, so now here's what I want you to add. I want you to add 132 meters from A to B. Alright? So now we're going to set up an equation. We're going to use the law of cosines here. And we're going to set up the equation trying to find the distance between D and A, or what we have labeled as little b. Alright, so our law of cosines. B squared is equal to 132 squared plus A squared, all right, because this is, we're trying to find B, minus 2 times 132 times A cosine of 75. All right, so all I did was I plugged back in to the law of cosines. All right, so I'm trying to find B, so then I'm going to use the other two sides as the other two parts of my law of cosines. All right, so remember, this is an isosceles triangle, so we know that A and B are going to be equal. So to reduce the variables, we can substitute B for A. All right, I'm trying to just get rid of variables. So I can rewrite it as B squared is equal to 132 squared plus B squared minus 2 times 132 times B cosine of 75. All right, since I know that A and B are equal, I just went ahead and substituted B in for A. That way I did not have to deal with two variables. All right, so let's see what we can do here. I can go ahead and simplify. B squared is equal to 132 squared plus B squared minus 2 times 132 is 264 times B cosine of 75. All right. Now, if I subtract B squared from both sides, I get 0 is equal to 132 squared minus 264 B cosine of 75. All right. Remember, I'm trying to solve for B. So now let's think about what am I going to do. Well, I'm going to add 264B cosine of 75 over. So I get 264B cosine of 75 is equal to 132 squared. I would divide by 264 cosine of 75 to give me B. So B is going to be equal to 132 squared over 264 cosine of 75. All right, so let's figure that out. All right. So I'm going to square 132 first. Then I'm going to divide that by 264 times the cosine of 75. And I get that B is approximately 255 meters. All right? Seems like a lot of work. All right, exercise number 3, last question. Parallelogram ABCD has sides of lengths 44 millimeters and 26 millimeters, and one of the angles has a measure of 100 degrees. Approximate the length of the diagonal AC and to the nearest millimeter. All right. Okay. So in parallelogram ABCD, the measure of angle D is equal to 100. Why do I know that? Well, I know that the measure of angles, let me re-speak for a second. The measure of angle C is equal to 100, which means since angle C is 100, angle A is 100. Alright? The measure of the four angles in a parallelogram equal 130 or 360. So if A and C are 200, that leaves 160 to be divided among the other two. So that means that angle D must be 80 degrees. Alright? Alright, so we're going to let D, the little d, represent the length of AC. Alright? So I'm trying to find little d here. We're going to plug it in to the law of cosines. So I'm finding d, so d squared is equal to, and the reason I'm using this triangle here is because I know the two measures of the angles. Alright, so is equal to 44 squared plus 26 squared, alright, minus 2 times 44 times 26 times the cosine of my angle, which is 80. The included angle, the angle between the two sides that I know. Alright? So, let's go ahead and look at this. So I have d squared is equal to 44 squared. I tell you what, let's just go ahead and figure this out. So that's 1936 plus 676 minus 2 times 44 times 26 is equal to 1. I don't think that's right. 2 times 44 times, I put plus 26, is equal to 2,288 times the cosine of 80. Alright, d squared is equal to, let's go ahead and add 1936 plus 676. So that'd be 2612 minus 220 cosine of 80. Alright. So now I can do this. 2612 minus 2288 cosine of 80 gives me that d okay, so I get d squared is equal to 2214.69. I have to take the square root of that. So d is equal to, and it tells me to the nearest millimeter, I get 47.0605, so 47 meters, or millimeters, sorry. Alright? Alright guys, if you did not write down the law of sine and the law of cosines, you need to make sure that you go back into the video and look at that and write those down, because they are going to become something that you're going to want to remember. Alright guys, hope you have a great rest of the week, and we'll talk to you next week.